Hello, this is Professor Sabatini at Passaic County Community College, and today we're going to be doing the first experiment for the Chem 111 General Chemistry class on density. Right? The density is a physical property of a substance. A physical property is one that can be observed without changing the substance into another substance. Other common physical properties would be like the color of something, if it has an odor, or its melting or boiling point. Any of those properties, you don't have to change the substance into another substance to observe that property. And density is one of those. Um, the density is also an intensive property, meaning that it does not matter the amount of material that you have. The density always remains the same. The density of pure water in a water bottle that you would be drinking would have the same exact density if you had a swimming pool full of pure water. All right, so the amount does not matter, which makes it an intensive property. The density is found by dividing the mass of a substance by its volume, and the units are most commonly used are grams per milliliter. Grams, mass in grams divided by the volume in milliliters, which is what we're going to do today. In this lab, we are going to find the density of a metal cylinder, and we're also going to find the density of a liquid. Right. So first, we're going to find the density of a piece of metal here. All right. And if you look, I have two different pieces of metal. Right. One is this shiny silver color. The other one is, we'll call it brass color because it's brass. All right. And one thing you would notice if you were holding these is they're roughly the same size, right? But this brass piece is much heavier than the aluminum, right? If they're the same size, they have roughly the same volume, right? But this brass piece is going to have a higher mass and a higher density, and I can feel that. Aluminum has a very low density for a metal, and this brass is much heavier, right? So that's kind of how you can like relate density in real life. You can feel like how heavy something is really. All right. So in order to find the density of this, I need to find its mass and its volume. So the first thing I'm going to do is find the mass. I'm going to weigh that on the balance. Make sure your balance says 0. So I'm going to hit the tare button there so it says 0. Then I'm going to put the metal right on there. I'm going to record its mass. The mass is 19.502 grams. All right, we always write down all of the numbers from the balance. The balance is accurate, so you do not round the numbers. Write all of them down. Now, to find the volume, I'm going to find the volume of this metal by displacement, which means I'm going to put a volume of water in here, all right, record that volume, then I'm going to add the metal to this graduated cylinder and then record the new volume. The volume will increase by the amount of the volume of this metal. So I'm going to put between 50 and 60 milliliters of water in here. All right. Make sure that you don't have any bubbles in there. The bubbles will they can dislodge and throw off your reading, right? Because the bubbles are not the liquid. All right. Now, when I read the volume of anything, but in a graduated cylinder or later a burette, the water or the liquid in there forms a meniscus. It sticks to the sides there, and it makes like this concave surface on the top. What you want to do is you want to read the bottom of the meniscus, which is right in the middle. So you want to get it eye level, and then I want to look here, and I have this graduated cylinder goes up to 100 milliliters, and the little graduated marks are each a milliliter. So I look, and this one is 50. It's in between 59 and 60. Now I can estimate that decimal place there, within reason. So I'm saying that's a little bit closer to 59. So 59.3 milliliters is the volume. Now, I'm going to carefully, without spilling any water or breaking anything, put this piece of metal in here. So, diagonally, slide it in there. Oh, look at that. Make sure there's no bubbles. All right. Now the volume is increased. The amount that it increased is the volume of the metal. So I read again, and now I have a 66.8 milliliters. So I take this volume, I subtract my first volume, and that would give me the volume of the metal. Since I already recorded its mass, the mass divided by the volume is the density. Okay? And that's how we do the density of a metal object, like that. The other density that we're going to find is of a liquid. All right? Now, we still need the same thing. We need the mass and the volume. For a liquid, the volume is pretty easy. We're just going to use a smaller graduated cylinder and put the volume, some volume in there and record the volume. The mass, however, is a little bit different. So what we're going to do is take an empty graduated cylinder, and I'm going to weigh it. It weighs 34.712 grams. Write down all the numbers. All right. Now, when I take this out, I'm going to add between 5 and 6 milliliters of this mysterious liquid to the graduated cylinder. Perfect. Alright, again, take the graduated cylinder, and I'm going to read the bottom of the meniscus at eye level. This graduated cylinder has marks that represent the decimal places, so it goes from 1 to 10, and each line in there is a decimal place. So now I can estimate to 2 decimal places. So I'm going to look, and I've got 5.1, and then it's in between the 1 and the 2. So let's say 5.15. So that's the volume of my liquid. Now, try it off, I can reweigh it with the liquid in there. I get 38.967 grams. So the mass of the graduated cylinder with the liquid in it minus just the mass of the graduated cylinder will give me the mass of the liquid. I can take that mass, divide it by the volume, and I will get the density. Alright, if the density of water is 1 gram per milliliter, so if whatever this substance is, if it has a density less than that, it would float on water if it doesn't mix. And if the density is higher than that of water, it would sink in the water. And that's pretty much the density experiment 1 or lab 1 from Chem 111 on density.